Hey everybody, we are going to be doing just a refresher on uh, motion graphs, uh, position versus time. So 513 is making observations about two-dimensional motion. So what I want to make sure is we remember these motion graphs. So let's see if I can zoom in a little bit. Yeah, that's just me moving the camera. Boom. Movie magic. Okay. A couple of things just to refresh, right? What's a horizontal line in a position versus time graph mean, right? It means I'm at, say, this is 5 meters, right? Position. I'm at 5 meters constantly, right? So horizontal line means I've got constant motion, right? Or constant position, which is kind of lame. It just means I'm standing still. I'm going to see if I can improve the angle on this a little bit. Okay. All right. So this really is meaningless because we're not going to make observations about something that's not moving. We are going to make observations of things that are moving. And the first thing we want to do is something that's in constant motion, like a constant rate. And so when we did a position time graph, we showed a graph like this, and this has a constant slope, right? And that constant slope was our velocity, which is our change in our rise over run, right? For this graph is my rise is change in my position over change in time. This is my velocity, right? And if my velocity has the same slope, it's a line, there's the same slope, my velocity is constant, right? Now, what's the slope of this line? It's 0. This would be change of velocity over change of time, so my acceleration would be 0 meters per second squared. So now what's happening if I do have acceleration, right? If I do have acceleration, what's that going to look like? What kind of acceleration do I want to show, right? I'll do some positive acceleration. We do that, right? I've got some positive acceleration, which means on this graph, my graph is going to look like I've got changing velocity, right? Acceleration equals delta V over delta T. That's my rise over my run. So my slope of this is my acceleration, positive slope. And then what's that look like for this position? So what's happening? It seems like I'm starting slow and I'm speeding up, okay? So that means I'm starting slow, my slope should be close to 0, and I'm speeding up. So I've got a chart that looks like this. So if I have acceleration, my position versus time is curved. And if I have constant velocity, my position versus time is straight. Okay? So straight line versus curved line in my position versus time tells me, do I have acceleration? Yes. Do I have acceleration? No, but I can get that constant velocity 0. My velocity is changing, right? It's my little slope meter. It's increasing. We're going to say it increases at a constant rate. My slope is constant. Okay, so I've got constant acceleration. We're going to be looking at position versus time graphs for projectile motion from our lab that we do in class. We'd take video and do some video analysis, and that's what I'm going to go through in the next video. Okay? Talk to you soon.